Okay, we pick back up and we have a new rule for natural exponential, and so the derivative of e to the x is e to the x. And you can pause the video and write down these examples and attempt them. Okay, these are all pretty basic. This one's just y prime is e to the x by the definition. If you have a constant out front, you just have 2 e to the x. And in this case, we have a 10 out front. It's e to the x. Our next one, but if we have, we may have the case where we have d dx e to the u, where a u denotes that there's something more than just an x up there. So what we would do there is we would calculate e to the u du dx. Okay, this is another version of it. It's the more complicated version. So this is kind of the base case of an exponential. This is if there's a u, and u is something more complex than just our basic e to the x. So let's look at a few examples. Okay, so we have some cases to where our term up here is more than just an x. And so we're going to use this e to the u du. So the derivative of e to the 7x is just going to be e to the 7x. So I have y prom. That's just going to be e to the 7x. That represents our eu. Now you have the derivative of u with respect to x. And now what we have to do, the notation on that, we'll write it the first few times, and as we'll say d dx of the exponent. So to calculate that, we'll just have e to the 7x. What is the derivative of 7x? Just 7, yeah. So we can pull that out front. So y prime is 7 e to the 7x. Now, like I said, when we do this, we'll be able to go straight from here to here, but I want you to see the trail of notation just for these, the introduction of this. All right, likewise on this one. So f of x is 3 e to the 2x. So the derivative of that is just going to be e to the u. So that's going to be f prime of x is going to be 3 e to the 2x times the derivative of what the exponent is. So the derivative of 2x. So that's going to be 3 e to the 2x. What is the derivative? Now evaluate this. That's just 2. So what's our final answer? The 2 times the 3, that's already there. Good. So 6 e to the 2x. Okay, and although our exponent gets to be a little more complicated, it's still the same idea and the same concept. So our f prime of x is going to be our e to the u. Whoops. And then we have times the derivative of our exponent. What is this? What does this term simplify to? 2, yes. So f prime of x is going to be 2 e to the 2x plus 4. Good. Okay, so if we have a base raised to a variable exponent, our a to the x is equal to a to the x natural log of a. So you can pause it and write those two examples down. This is our most basic case where we just have x as an exponent. Y prime is going to be a to the x, and then natural log of a, so that'll be natural log of what? 2. Good. And over here, f prime of x is just going to be 5 to the x, and then we'll have the natural log of a. In this case, a is 5. All right. Just like our exponential, we also have the form in which a to the u, so we have a more complicated exponent basically. When that happens, it's going to be defined by a to the u, natural log of a, so that part, but then we also have to take into account for the derivative of the exponent, so du dx. So for example, if I have y equals 2 to the 7x, or f of x is equal to negative, let's just do positive 3. Let's do 3, but to a negative exponent, to the negative x. Let's look at these two cases. Okay, so y prime here is just going to be a to the u, which is, this is a to the u, times, what is it, natural log of a, so that's natural log of 2, and then I need to multiply that by the derivative. Du dx would be the derivative of here, so let's say d dx of 7x. I'll calculate this in the next step. 2 to the 7x, natural log of 2 by the definition, and then what's the derivative of 7x? Yeah, times 7. So y prom is just going to be 7 times 2 to the 7x, natural log of 2. All right, f prime of x over here is just going to be a to the u. So we write down our a to the u, and then we do natural log of a. Then we have to account for the derivative of our exponent. Okay, so we're going to calculate this. What is the derivative of negative x? Just a negative 1. So this is negative 1. So there's my negative 1. And I bring everything else down. Okay, we'll look at some logarithms. So the derivative of a logarithm is just going to be 1 over u times 1 over the natural log of a times du dx. All right, so we'll have two examples to go with here. Y prom is going to equal to 1 over u. So what's 1 over u? 1 over 5x, good, times, we want to do 1 over the natural log of a. So 1 over the natural log, and what's a in our problem? 2, good. And then we have du dx, so we want to take the derivative of 5x. The derivative of whatever this term is here. Alright, so it's just going to be y prime is equal to 1 over 5x. I'm just bring these down. Natural log of 2. What is the derivative? Let's go ahead and calculate this right here. What is the derivative of that? 5. Okay. Now what about the 5 here and the 5 here? They'll cancel each other out. Good. So this will simplify with this. So our y prom is just going to leave us with 1 in the numerator and x natural log of 2 in the denominator. Yeah. That looks like. Alright. Pause it. Go ahead and try number 2. You could do that one on your own. It's similar to 1, and then check your answer. Okay, so you should get f prime of x to be 1 over x natural log of 7.